Okay, today we're going to go on. We're going to start section 1.3, which is on angles. We've been doing all kinds of stuff involving segments primarily. Today we're going to turn to angles, and you're going to find that there are some things that are very similar between segments and angles. Some things are different, but some things are pretty much the same. So first of all, the definition. An angle is a figure made of two rays, called the sides, with the same endpoint, called the vertex. So for this particular angle, the sides are ray SR and ray ST. It must be, when you are asked to name sides, it has to be a ray, and it has to start at the vertex. So it has to start at S, which is the vertex for this angle. What names do we have for this angle? Well, what you can do is you can name a point on one side, the vertex, and then a point on the other side, just like you were drawing it from R to S to T. Or you can start on the other side. It doesn't matter which side you start on. You can call it TSR. And since there's only one angle with a vertex at S here, you could call it angle S. Basically, when you say angle S, you're saying the only angle in the picture that has a vertex at S. And that's what you're saying. So if you have an angle on a plane, and if you draw an angle on a piece of paper, it's on a plane, because a piece of paper is flat just like a plane is. Every point in that plane is either in the exterior, on the interior, or on the angle. So for example, if you will add these also, if we put point A here, so A is in the interior, B is in the exterior, and C is on the angle. Okay? So every point on your piece of paper, once you've drawn an angle, is either in the interior, in the exterior, or it's on the angle. One of those three. Now, if you have more than one angle that have the same vertex, that's the point of the angle, then you can't name the angle by its vertex. So we're going to look at these. In this diagram down here, notice there are actually three different angles. So these are the angle names. This angle on the top, we can call angle 1. Please stay with us. We're on page 1 still. Thank you. We can call this angle on top angle 1 because of this 1 here. We could also call it BDA or ADB. Again, you name a point on one side, the vertex, and then the other side. So what are the sides for that particular angle? What are the two sides? I'll take a volunteer. Yes, sir. Go ahead. A is a point. A is not a side. Yes?
BD and AD?
Close, but not quite. Yes?
Side DA.
Ray DA. And what's the other side? DB. And what is the vertex? D is the vertex. The sides have to be rays. They can't be points. They can't be lines. They have to be rays. So for this angle down here on the bottom, angle 2, we could also call that angle BDC or CDB. Let's name the sides for that one. Alicia, you want to give that one a whirl?
Is it CD?
We got to start.
Or would it be DC?
Yeah, it's got to start at the vertex. So ray DC. And what's the other side?
DB.
DB, exactly right. And the vertex for that one is D. So for the whole big angle, we could call it angle ADC or angle CDA. We can't name it by a number because there's not a number that's just in its interior. So Braden, how about giving me the sides of the big angle? So we're talking about this whole big angle here.
So DC.
And you mean what DC?
Ray.
Ray DC, good.
And Ray DA.
Exactly right. And the vertex is again D. This is why you can't name any of those angles angle D. Because if you say angle D, no one's going to know which of the three angles you're talking about. All right, page 2.
Yes, that's great. We're going to talk about this. I'd like you to stay with us.
All right. So classified angles, you learned this probably in junior high, maybe earlier than that. Acute angles, that's a small angle. You know, the joke is always it's a little cute angle, right? It's less than 90 degrees. There's a right angle whose measure is 90 degrees. Obtuse is greater than 90. And then a straight angle whose measure is exactly 180 degrees. Your book actually tries to play both sides of straight angles. In one point of the book, it says there's no such thing in a straight angle. And then in the homework, they give you a straight angle and say, what kind of an angle is this? And you're supposed to tell them it's a straight angle. Sometimes the people who write the text and the people who write the problems don't talk to each other as much as they ought to. Okay? So, this down here, this is called a protractor, and it's used for measuring angles. We won't use it a whole lot, but there are some questions on your homework tonight. So let's take a look at, first of all, we'll do some really easy ones. For example, if I ask you, what is M? The M stands for the measure of angle, that's my angle symbol, AXB. And the question always becomes, well, there's two different scales. There's an inside scale and an outside scale. The question is, which one do you use? Well, notice on this one that side XA, this ray, goes through 0 if you use the inside scale. So I'm going to use the inside scale for both of them. Ray XB goes through, looks like 42. So that's just 42 degrees. So if one of them goes through 0, it's real easy to find the measure. So if I want to find the measure of angle, let's find the measure of angle CXA. Notice ray XC goes up here, ray XA goes over here. If I read the inside scale, I can use the 0. So I should use the inside scale for this, so that's just 110 degrees. Excuse me a second. And that's fine if one of the sides of the angle goes through 0. But what if it doesn't? What if I want to know the measure of angle DXC? Neither one of the sides goes through 0, does it? For this one, what we're going to do, it's a little bit like what you did on a number line for finding out how long the segment is. You're just going to take the big number minus the small number and subtract. And you can use either the inside scale or the outside scale. It does not matter. So let's say we're using the inside scale. This is what, 160? And that's 110. So we could do 160 minus 110 is 50 degrees. So what kind of an angle is that? Acute. All right, let's do another one. Let's do angle DXB. Neither of them go through 0, so I can pick either scale I want to use. Let's use the outside scale this time. So this goes on the outside scale, goes through 20. And what does XB go through? 138. So I can just do 138 minus 20 is 118. What type of angle is that? Obtuse angle. Okay? So if neither of them goes through 0, pick one of the scales, but use it for both. Don't use the inside for one and the outside for the other. That's not going to work so well. All right, let's move on. So congruent angles, just like you had congruent segments. Remember congruent segments, we put our hands together and said your hands are basically congruent. They're the same shape and the same size, right? Same thing with congruent angles. Congruent angles are angles that have equal measure. Notice the objects are congruent, their measures are equal to one another. Okay? So my index fingers are congruent to one another, and their lengths are equal. Two different ways of saying it. We never say my fingers are equal, because they're not. Okay? Equal is reserved for numbers. All right, page 3. Just like we had a segment addition postulate, we also have an angle addition postulate. So the angle addition postulate says that if a point is in the interior of an angle, then the sum of the measures of the two smaller angles is equal to the measure of the whole angle. So on this one, start with the big angle, PQS. R is in the interior. Because R is in the interior, then the measure of angle PQR, which is this angle over here, and some people like to color in the interior. When you're talking about PQR, you're talking about all of this angle over here, plus RQS, all of this angle over here. Basically, you're just taping those two angles together, and when you do, you get the measure of the whole big angle, angle PQS. All right, so let's do an example problem together. So in this diagram, it says the measure of angle ABD is 35 degrees. And the measure of angle ABC is 81 degrees. Well, ABC is the whole thing, isn't it? So the angle addition postulate says the measure of the two small angles, ABD and angle DBC, added together gives you the measure of angle ABC. Well, I know that ABD is 35. And ABC is 81. So I've just got to subtract 35 from both sides of that. And that's going to be 46. You do not necessarily have to show me all of that. I do expect to see from everyone at the very minimum that you're subtracting those two to find it. If you can do that without writing out the equation, that's okay with me. Okay? All right, this one doesn't have a diagram. We have to draw our own. Okay, it says J is in the interior of angle CTD. So, I want to draw an angle CTD. I usually make it an acute angle. I don't know how big it is yet because they haven't told me. So I have point J somewhere in the interior. I'm not going to put it exactly in the middle because they didn't tell me that. Of angle CTD. C is on one side, T is the vertex, D is on the other side. So that's the first part. J is in the interior of angle CTD. Then it tells me the measure of angle CTJ. Well, I need to draw in ray TJ in order to have angle CTJ. So that's 32. JTD is 29. And I want the measure of angle CTD. What do I need to do to these two angles to get the measure of the whole thing? Just add them, yeah. So it's just going to be 32 plus 29 gives me the measure of angle CTD. Oops. Angle CTD. So that's 61 is the measure of angle CTD. Yes, sir.
So do we have to like show that every time it comes out?
You're going to have to draw the diagram, otherwise you're not going to know whether you're supposed to be adding or subtracting.
Yeah, I'm not talking about diamond, I'm talking about problem.
You need to show me that you're adding.
Well, yeah. Since we started adding it, kind of broke.
Oh, if you wanted to just do, so you're saying you just want to do 39 plus, or 32 plus 29 is 61, that's fine. I'm just showing what we're doing. All right. With a segment, what was it that split a segment into two congruent parts? The what? Bisector, or better, yeah, the midpoint. The midpoint divides the segment into two congruent segments. Just like that, an angle bisector is a ray that divides an angle into two congruent angles. So this works exactly like the midpoint works. It's going to take that one angle, divide it into two parts that are congruent to one another. Okay? So let's take a look at these last two problems. For this first example, it says ray AB bisects angle JAL. So I need a diagram for that. And again, I usually start with a big acute angle, unless somewhere I know for sure I've got an obtuse angle. And I want ray AB to be splitting that angle right down the middle. So A's got to be the vertex. J has to be on one side of the angle. A is the vertex. L is on the other side of the angle. And remember, with segments, we put a little slash across them to mark that they were congruent. For angles, what we'll do is we'll draw a little arc like this. Notice I offset those. If you draw them at exactly the same distance from the vertex, it looks like it's just one big arc. Okay? Some older textbooks, I'll just show you real quick, and you can do this if you like, will do this, and then they'll mark to say those two are congruent to each other, kind of like what we did with the segments. Whichever one you prefer. I kind of like this one because it's fewer markings. Then it says the measure of angle JAL is 84. So this whole thing is 84 degrees. What do I need to do to that to find the measure of JAB? Divided by 2, yeah. 84 divided by 2 is 42. So both of these are 42 degrees. It divides the one angle into two smaller angles that are congruent to each other. All right, one more example. Here it says ray CD bisects angle ACB. Tell you what, I'm going to give you a moment. Draw that. What should that look like? All right, so it's supposed to have ray CD bisecting angle ACB. So again, I'll start with a big acute angle. CD is supposed to be bisecting it. So that's ray CD. A has to be on one side. I usually put the first letter on the top, but it doesn't matter. You could go the other way. B has to be on the other side. What am I missing at this point? The what, I'm sorry? There are no coordinates in this. Oh, I'm just to this point right now. I'm just to this point right now. I have no degrees yet. I have only read this far and I've drawn this. This is not good enough yet. Yes?
The markings to show that
Yes. You got to mark that those two angles are congruent. Very good. Then it says the measure of angle ACD is 46 degrees. So what do I immediately know? Yeah, this other angle is 46 degrees. And that's what they asked. So the angle is 46 degrees. Yes?
Will we get points taken off if we don't write that?
No, but the problem is if you don't mark it, you may forget it.
Yeah.
And what's going to happen is later on when we get to like triangles that have multiple angles, we'll need to know like this angle from this triangle is congruent to this angle from this triangle. So it's a real helpful way to mark, oh, it's just this one congruent to that, not all the angles.
Okay.
Okay? Yes?
So you know how there's like A, D, B, and they call it dots?
Yes?
Is it okay if I like connected them?
A, D, and B, you can if you like. I don't know that there's any benefit to it, but it doesn't hurt anything either. Any other questions? Okay, we still have some time left in class, almost 20 minutes at this point, so please go ahead and get started on your homework assignment. Yes? No, it's out of the book. I think it actually popped up on your feed last week, accidentally. It is, it'll say angles on it. It'll say 1-3 angles. It's in section 1.3. It should have popped up on your feed, I think, last week. Let me know if you have trouble finding the assignment, and I will give you a hand with it.